Hello everyone, this is Masth Electronics. Today we will be controlling a rover using our phone over Wi-Fi with the help of a NodeMCU. Here are the components we will be using. A freewheel and a PCB board to mount it. A 5V regulator which powers the NodeMCU, motors and ultrasonic sensor. Spacers to hold the batteries. Two PCB boards, one for the circuit and another to hold the batteries and motors. Two N20 micrometal gear motors with mounting brackets. An L293D motor driver circuit. You can buy a ready-made module, but here I have built mine manually. The circuit diagram is available in the description below. An ultrasonic sensor to detect obstacles. A red LED with a 220 ohm resistor for obstacle indication. The NodeMCU, the brain of our project. Bulk strip to mount the NodeMCU, motor driver and ultrasonic sensor. Two joystick connectors for the batteries. Two N20 wheels. And finally, two 4V lead acid batteries. Let's go through the circuit diagram. Connect the two 4V lead acid batteries in series to get 8V and feed it to the 5V regulator. The regulator output goes to the NodeMCU, the L293D motor driver and the ultrasonic sensor. On the motor driver, IN1 and IN2 control the left motor, IN3 and IN4 control the right motor, EN1 and EN2 are the enable pins which we will connect to 3.3V. Connect IN1 to D1, IN2 to D2, IN3 to D3 and IN4 to D4. Ultrasonic sensor trigger is connected to D5, echo to D6. A red LED with 220 ohm resistor is connected to D7. Now let's start building. Take the PCB board, place the NodeMCU with bulk strips and solder it. Similarly, solder the motor driver and ultrasonic sensor. Wire IN1 to D1, IN2 to D2, IN3 to D3 and IN4 to D4. Add voltage regulator, joystick connectors and solder the series battery connection to the regulator input. Solder regulator output to NodeMCU VIN and ground and also to the motor drivers VCC and ground. Connect EN1 and EN2 of the motor driver to 3.3V of NodeMCU. Solder motor driver output to bulk strips for easy motor connection. The 5V and ground of ultrasonic sensor is connected to motor driver VCC and ground, and the trigger pin of ultrasonic sensor is connected to D5 of NodeMCU and echo to D6. Motors are soldered with jumper wires for easy plug and play. Add a switch between the battery and regulator. Now when we power on the circuit, it works. Now let's build the rover. Before that, solder red LED with 220 ohm resistor to D7 as explained in the circuit diagram. Take the second PCB with pre-drilled holes. Mount the motor with brackets. Attach the freewheel. Fix the spacers and place the batteries in between. Mount the main circuit board on top. Connect motors and batteries to the circuit. Okay, the rover hardware is ready. Now it's coding time. The code is already uploaded on GitHub. The link is in the description below. Download and unzip the file. Inside you will find the circuit diagram and the Arduino code. Open the .ini file in the Arduino IDE. If you don't have Arduino IDE, you can download it from the official Arduino website. Let's go through the code that powers our Wi-Fi controlled rover with obstacle detection. We are using an ESP8266 NodeMCU to control the motors, read the ultrasonic sensor and send commands through a simple web interface. We start by including two libraries, ESP8266 Wi-Fi for connecting to Wi-Fi and ESP8266 Web Server for creating a web server on the NodeMCU. Here we set up our Wi-Fi name and password. Next we define the pins connected to our motor driver. We also define pins for the ultrasonic sensor, trigger pin for sending pulses, echo pin for receiving them, and an LED that will blink when an obstacle is detected. Our threshold is set to 10 cm. If something is closer than that, the rover will stop. A variable to store current command. Initialize server. The stop motors function turns everything off. These functions move forward, move backward, move left and move right, send high and low signals to the motor driver to control direction. Inside move forward, we check the ultrasonic distance first. If an obstacle is too close, we stop and blink the LED instead. The get distance function triggers the ultrasonic sensor and calculates distance in centimeters using the speed of sound formula. We have a simple HTML page stored as a string with buttons for forward, backward, left, right and stop. When you tap one of these buttons on your phone, it sends a request to the NodeMCU. In setup, we set all pins to output or input, connect to Wi-Fi and print the rover's IP address to the serial monitor. We then link each button's URL to its respective handler and start the server. In the loop, the NodeMCU constantly listens for client requests from the phone. If the rover is moving forward, we periodically check for obstacles. If one is detected, the rover stops and the LED blinks. Alright, now let's jump into the demo. First I will flash the code onto the NodeMCU and it's done. Next I'll go to the hotspot settings on my phone. This is the Wi-Fi name and password that I used in the code. Let's turn on the hotspot. And yes, the NodeMCU is now connected to my phone. I'll open the serial monitor. Here we can see the local IP address assigned to our NodeMCU. Perfect. This is the IP that we'll use to control our rover. Now I'll enter this IP into my phone's browser. And there it is. We have got our HTML control page with buttons for forward, backward, left, right, and stop. Let me try it out once. Yes, it's working. Now it's time to really test our rover on the floor. I'll switch it on, reset the NodeMCU, and once again connect it to the phone's hotspot. Remember, this IP might change after some time, like after a few hours or when the Wi-Fi router reassigns it. So you may need to check it again if the connection doesn't work. Let's go forward. Oh, look, it stopped right in front of the obstacle with a red light. Perfect, the obstacle detection is working. Now backward. Nice, it's coming back towards me. I'll stop. Let's try left and right. Everything is responding well. Here comes another obstacle, and yes, it's stopping automatically once again. Everything is working just the way we planned. Our NodeMCU based rover is live and running beautifully. That's all for now. Currently the left and right turns are a bit fast, so in the next video we will add speed control and other upgrades to make it more like a race car. Are you excited? Stay tuned. If you found this video helpful, give it a thumbs up and subscribe to our channel for more such projects. Got questions or suggestions? Drop them in the comments. We would love to hear from you.